Welcome to the video. Today we are going to solve another Math Olympiad problem which is on prime numbers. So a math teacher has 42 packets to give out to students. So to student A, the teacher gives X number of packets and the remaining is also prime. To student B, the teacher gives Y number of packets, then remaining is also prime. And to student C, the teacher gives Z number of packets, also prime, and remaining is even, non-zero. Now we have to find all the combinations of X, Y, and Z. So this is a question which is mostly about understanding the concept of how prime numbers or prime pairs work. Let's use the systematic plasma method. So problem understanding, as I just explained. So we got 42 number of packets. We have to find factors of it such that X and the remaining is prime, then Y and the remaining is prime, and Z is prime, but the remaining is even, non-zero. Linking of concepts. So we know that this is a case of finding the prime pairs. So as a background, a prime number is usually all odds. The only even prime number is 2, right? So let's list down some of the prime numbers until 42. That would make this problem a bit easier. So we start with 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there are 13 prime numbers less than 42. In terms of assumptions, so far we do not have any assumptions yet. It's just that we have to find different prime numbers. Then let's go to the next step, which is solving this question. So as you know that a prime number is made of is an odd number. So when two odd numbers combine, then we get an even. So when you split 42 into two prime numbers, you can get actually two different prime numbers from here. So let's try to find all the possible combinations of X and then the remaining packets. So let's call it R1. Let's call this R2. Let's call this R3. Let's see if we really need them. So X comma R1, this pair, the sum of it has to be 42. So if we start with 2 plus 39, 2 plus 40, not a combination. 3 plus 39, not a combination. 5 plus 37, one combination. Or either or vice, 37 and 5. But I'm just taking the pair. Then 7, 35, not a combination. 11 and 31, one combination. Then 11, 31, then 13 and 29, another combination. Okay. Then we move to 17, and then that will be 25. So not a combination. 19, and that will be 23. Okay. So 19, comma 23. Okay. Then 23 already we have all the combinations. So we have reached from both ends. So this is one pair, this is one pair, one pair, one pair. So we have 4 pairs where we have x. Okay. Then we know that R1 is an odd number. Now we have to again break it into 2 primes. One is here and one is here. So if both of those primes are odd, it has to sum up to an even value. But here we know that R1, the remainder of first one, is an odd. So one of the prime number has to be even. And which is the only even prime number? 2. So we have to take y as 2. So y will automatically come out to be 2, and that is the key here. So y is 2 for sure. Then R2 is something that we have to see, what is the different way we can fit, because we have a lot of excess that we can take it from here, and then we have to see what R2 can be. Similarly, Z and R3 can be, based on what we have as X, what we have as Y. Okay. If Y is equal to 2, then R1 cannot be 5, because if we take 2 out of it, then it will become 3 in R2, and then you cannot take any further Z or R3 out of it. So R1 has to be 37 here, but if you subtract 2 from it, this becomes 35, so that is not a prime. So we cannot use this pair. Now let's go to this. So if R1 is 31, then we subtract 2 out of it, then we get R2 as 29, so which is possible. If R1 is 11, then if we subtract 2 out of it, we get 9. So this can be R1 and this can be X here. Okay, now let's move to the next one. So if we subtract 2 from here, then this becomes 27. So this will not yield a prime number. If we subtract 2 from here, this will be 11. So this will yield a prime number. So this will be R1, and here this will be X. Then now here, if we subtract 2 from it, then this becomes 17. If you subtract 2 from it, this becomes 21, which is not prime. So this is going to be R1 and this is going to be the X. Okay. So far so good. So now we know that there are 3 values of X: 11, 29 and 23. And Y is 2. Then now we have to find the Z. So R1, now we know that X can be 11, 29 and 23. And similarly, R1 correspondingly will be 31, 13 and 19. We know that Y is equal to 2 always. So then what will be R2? So let's say if X is 11, so let's put here 11. For X value of 11, R2 will become 31 minus 2, 29. When X is 29, R2, then this will become 13. minus 2, that will be 11. And when x is 23, then R2 is equal to 19 minus 2 is 17. So we got 3 values of R2 corresponding to 3 values of x. Okay. Now we have x, now we have y, and we have all the R2s. Then based on this R2, 29, 11 and 17, now what we have to do is, we have to just split it into one prime number and one even. So as long as we find one prime number from this list, we are good, because the other number will become an even automatically, because we are subtracting an odd from an odd. For x is equal to 11, R2 is 29, so z can be all these values before 29 except 2, because if z is 2, then R3 will become odd. So 3, 5, 7, 11, 13, 17, 19 and 23. So there are 3, 5, 7, 11, 13, 17, 19 and 23. So 8 values. Next, for x is equal to 29, R2 is 11. So when R2 is 11, then we can only take 3, 5 and 7. 5, 7. So 3 values. And then the last one, for x is equal to 23, here our R2 is 17. So z can be 3, 5, 7, 11, 13. 3, 5, 7, 11, 13. So 5 values. So now we have 8 combinations from here. For x is 11, y is anyway 2 always, x 11, and z can be 3, 5, 7, all these 8 values. For x is 29, y is 2, and z can be 3, 5, 7. And for x is 23, y is 2, z can be these 5 numbers. So these are our 8 plus 3 plus 5. So this is total 16 combinations. Total x, y, z combinations will be 16. And that's our answer. Hope you liked this video.